Hello, everyone. Welcome to the Thomas Expert Series. We're going to get started in just another minute or so. I just want everyone to double check their microphones, make sure everything is muted. This talk will be on demand within 24 hours, so please let your colleagues know how much you enjoyed the presentation today and direct them to the On Demand tab or sign up for future talks. To get everyone started, I'm curious where everyone is tuning in from. I'm in New Jersey. Jesse, where are you at?
Massachusetts.
Awesome. And we've got New Jersey in the chat. More New Jersey.
Canada.
Canada. Cool. California. All right, let's go ahead and jump in. Here today is Jesse here to talk about certified sustainable and safe ductless air filtration solutions.
Thank you, Heather. Good afternoon, everyone. It's always a pleasure to have the opportunity to present during these expert series. So before I start, maybe everybody can chime in. Do you know why I have 8 liters of what looks like chemical bottles in front of me and the significance behind them? I'm curious if anybody just wants to participate in that question. Give you about 10 seconds. Nobody has it. So we breathe 8 to 10 liters of air per hour. So this represents the amount of air we breathe, every single minute. Why that has significance? Obviously, we would not drink polluted water. We would not drink 8 liters of polluted water had it be in front of us, right? We would stay away from it because we know if we ingest pollution, it's going to certainly impact us and we're going to get very sick. Same with the air we breathe. We don't think about that because we can't see the air we breathe. We can't see the nasty stuff around us. And I always say if we could only walk into a room and if we could start seeing particles and chemicals all around us and they would turn red as they were moving around in the air, we would be reluctant to go pretty much everywhere. So it's very critical in the air we breathe. It's really what I'm going to talk about today is the pollution factor involved in laboratories and how we improve lab safety. But I'm also going to touch on the sustainability aspect of our product. So what does ERLab do? ERLab's been providing filtered solutions for the protection of laboratory personnel for over 55 years. It's been our sole focus. We started the company as a mobile casework company and quickly evolved to a safety company, providing what you see behind me over here, the small little ductless enclosures. Invented it in 1968. So we invented this technology and we continue to innovate. Therefore, we are the world leaders in this technology. Now, when I talked about a holistic approach to lab safety, everything you see in my room here is independent from the building's infrastructure, completely filtered. And of these products, we have whole room air filtration systems, which mitigate the risk of fugitive emissions in your laboratory and outside of the laboratory for any type of bioaerosol concerns or PM 2.5 concerns or just generalized pollution. Then, of course, we have a full array of filtering fume hoods from single wall constructed hoods to partnerships with Lab Conquer, where you have a traditional research style fume hood with the sliding stash and side mounted fixtures, turrets, and things of that nature. And of course, we have storage solutions, integrated solutions for flammable cabinets. And why is that important? I always like to point that out behind me. Very important because these tend to be the most noxious cabinets in a laboratory. You store chemicals there, they sit, they stagnate, and those chemicals gain concentration. So when you open that door, you are literally lofting concentration in front of your breathing zone. And the purpose behind all of these products is to reduce, again, the pollution loads that we're exposed to. And we all react very differently to the TLVs of any type of chemical. We have OSHA, NIOSH, and ACGIH that set certain limits and criteria of what we can be exposed to throughout our working career. But there's many discrepancies. I was actually just having a conversation with the client earlier this afternoon, and we were talking about that very same thing. Is they comply to ACGIH, but most facilities comply to OSHA. You just don't know what the concentration levels are, how they're going to infect a certain individual. Pollution to methanol or exposure to acetonitrile to me could affect me completely different than it could affect somebody else on the call. So we really have to go above compliance, beyond compliance, while improving safety. The additional advantage of this technology and filtration is the flexibility behind the product. You can literally install this product anywhere without limitations, anything you need. So if you have a piece of equipment, an HPLC, a rotovap, titrators that are just an open bench chemistry, and you really don't have capacity within your lab to add a ducted fume hood, you can literally put, as you see behind me, you can put the equipment inside that enclosure, and now you create a barrier and you're continuously filtering those emissions. And we also have the sustainability aspect of the product. Because this product is not ducted to the infrastructure, what do ducted fume hoods do? Ducted fume hoods consume a tremendous amount of energy, a tremendous amount of air. Air costs money. On average, a lab consumes about 57 to 65% of a facility's overall energy use intensity. And they only account for about 25% of the square footage of space. So there's a significant impact in energy when it comes to ducted fume hoods. And as we have to start adhering to sustainability initiatives, and we have local legislation in Boston called BERDO, you have local law 97 in New York, you have St. Louis initiatives, which legislation just passed, which basically state any facility greater than 25,000 square feet must be in compliance and have a sustainability initiative and program outlined by 2028 and implementation by 2030. We know that without our technology, labs will not be able to achieve these initiatives. And we have case stories on how we've helped facilities achieve ZNE simply by installing filtered fume hoods. They become the cornerstone to sustainability. So with that, let's dive deep into the numbers of cost and the impact of ducted fume hoods and what happens when we install filtered fume hoods and how that impacts our overall lab and the processed airflow within that facility. And I think Tammy's going to try to share her screen here. But while she's working on sharing her screen, again, I'll touch on some of the products. I'm going to certainly dive deep into the safety aspect of this technology because it's obviously without safety, who cares about sustainability? We have to be able to guarantee the safety of the product. So let's talk about the numbers of ducted fume hoods and filtered fume hoods and how this impacts the overall lab. Well, what you see here on this screen, this is a traditional chemistry lab. So a high hood and density lab, 10 fume hoods. We take those 10 fume hoods and we only make 3 of those fume hood ducted. Tammy, can you go back to the previous slide, one slide before this? You have it?
I don't.
Okay, so the slide before this shows the impact of all these hoods being ducted. If these hoods are ducted, that CFM that you see, that 5,250 CFM savings, that's because those ducted fume hoods, when you have the sash lifted, you're now processing a CFM max of about 7,000 to 8,000 CFM. You see it crossed out above on the upper hand right-hand side. So if you take those 10 hoods that were ducted and best of both worlds, keep 3, 2, maybe 4 of them ducted and the remainder are filtered, and you see the overall impact that filtration has. Why keep some ducted, you say? We need air changes regardless in a laboratory. We need about 4 to 6 air change rates in the laboratory, depending upon the classification, but on the normal, between 4 to 6 air changes. So having some ducted fume hoods is never a bad thing. It's not going to impact the HVAC. It's not going to impact the energy load. You're going to need those air change rates. But then if we can take that and reduce the overall load with filtration, you see where that savings comes in just in CFM alone. Now, one ducted fume hood consumes that amount of energy of about 3.5 US homes. So factor that into the cost. Now, this just talks about the CSMF savings and then the dollars. But then a few slides down, we're going to actually look at the CO2 emissions released from these fume hoods. So next slide, Tammy. There we go. So when you look at the CO2 impact of ducted fume hoods versus filtered, it's significant. Savings is important. We all need to look at our bottom line. You can clearly see the savings there. We have two different side-by-side scenarios, 26 hoods operating at 2,000 hours a year and 26 fume hoods operating at 8,700 hours a year. Obviously, constant volume hoods constantly on. And you see the impact of both of those scenarios. You see the CO2 emissions. Actually, you're about 2.5 million pounds of CO2 emissions had you have those 26 fume hoods on a CV system. Now, we have to factor in filter replacement. So we know for sure these are filtered fume hoods, and the question's going to be asked, and I'll probably end up answering it. You have to replace these filters about every 24 months, depending upon the variation of chemistry being performed in the hoods. So we have to factor that into the overall cost. And you actually see the bottom highlighted area, the total annual savings with filtered fume hoods, factoring in replacement of the filters. So one of the misconceptions with ductless fume hood, ductless technology, is that you have to replace the filters far too frequently. The cost is going to be offset. We're not going to save anything. The bottom line is not going to be impacted. That's a false statement. You can clearly see where the savings is there, but more importantly is the CO2 emissions, because again, remember those sustainability initiatives, unable to achieve it with a hood intensive lab under a ducted fume hood system. Next slide, please, Tammy. So one thing I love to talk about is, what about the filters? The filters, they just go in the landfill. So how are you green? Well, these filters, I have a filter here. So these are about 30 pounds of filters, very robust filter. Remember, we're capturing and containing. We're not throwing conditioned air out into the atmosphere to just recondition it through our heating, cooling towers, and everything else that's involved with processing the overall airflow. Capture and contain the pollution at the source in these filters. When these filters are used, they then get shipped to us, and we have an environmental service company, or you have your own environmental service company, run them through an incinerator. Now, not many people know that the incinerators contribute to 14 megawatts of clean energy. How? Well, obviously, you incinerate the pollution. So now this is a pollution source because we have adsorbed chemicals, but then you create steam. That steam creates clean energy. Then you scrub that steam and through that 3-stage filtration system, sometimes a 5-stage filtration systems in these incinerators, and out the stack comes clean flue gas. Now, one of these filters, once incinerated, contributes to 73 kilowatts an hour of energy. So it's substantial, and they go down to about once incinerated to about 3/4 of a cup of ash. So we really have a cradle to cradle process. Don't just use these and dump them. We use these for good measure and to contribute to clean energy back into the atmosphere. Next slide, Tammy. Now, these incinerators have to obviously adhere to strict EPA regulations, which means for every 10,000 molecules that may be released, only one can be released at the filter's exhaust. Very similar to our safety standards, which I'm going to touch on next. But understand these, I used to look at incinerators and go, man, look at that steam just plummeting out of those plumes. Wow, thanks for the pollution load. But when you start investigating it, now I've been with the company 15 years, so I've known this for quite a while. But when you start investigating it, you realize we can do this right. There's really a good way to do this. It's a good way for laboratories to have better practices to play our part in stopping global warming. Next slide, Tammy. I think that's it. So we're going to go into the case studies in a moment, but I want to talk about safety behind the product because that's critical. Tammy, if you could just stop sharing your screen for a moment. Thank you. So what is the safety standards we have to adhere to? First and foremost, we have to adhere to a standard called the AFNOR NFX 15-11 standard. And that's really a standard based on the filtration efficiency of a ductless fume hood. We are the only company to adhere to this strict standard. And what do you need for this standard? You need to make sure you have a chemical listing that's published that provides a list of chemicals, which we have, which are 750 chemicals tested under 6 different concentrations twice. But not only do we need to know the molecules and the chemicals that we can retain, we need to know down to the molecular gram of those chemicals we can retain before we see release not exceeding 1% of the threshold limit value. Then we must be able to provide different levels of safety, different processes. Now, before we even provide a product to a customer, we have to do a feasibility study to determine that the filters are going to first be applicable based on their application and overall handling, but then provide a total life cycle of those filters. Like I said earlier, on average, it's about 24 months before we have to rotate out the filters. Okay, that's at which point the hoods are operating under normal operating conditions. And again, what does that mean? With our filter stack, we can configure this in many different ways. What you see here is a primary carbon filter, a fan module, and then a secondary carbon filter. I have it removed here purposely. Under normal operating conditions, again, we say that the filters are going to last 24 months. That is our guarantee. It's our liability. It's our guarantee that this filter right here is going to last 24 months. When that 24 months is up, we have safety specialists in the background that ensure that the filters are replaced according to lab recommendations. We have sensors built in to ensure that if we do have any spike in concentration, we're detecting that. And of course, redundancy to scrub anything that may have bypassed this primary filter prematurely. But let's say nothing's bypassed. It's been 24 months. Now you have to replace the filters. This filter gets disposed of through the incinerator. The top filter rotates down to become the primary, and then the new filter becomes your secondary filter. Let's say you didn't rotate the filters. 24 months have passed, you let it go, nothing's alarmed, we have dry contact metal oxide sensors in here, we're good, we haven't seen anything come through the filters. Okay, and now you see a detection. You've seen a spike, the hood's alarmed, it let you know that, hey, we've had a break. What does that mean? Does this mean now you're exposed to 100% of the TLV? Absolutely not. We still have to guarantee during detection phase that there will not be release exceeding 1% of the TLV past this filter's exhaust. Now, you continue to see the hood alarming. Now, you see these lights across my products, around the halo above me. That's a purposeful light. That's smart technology. And basically, if that light pulses, it's an indication that we've experienced either breakthrough past the primary stage of filtration, a phase velocity alarm, or a mechanical error in the fans. So let's say we've been at detection phase, it's continued to go off, the alarm, it has not remediated, and then you have a spill on the hood. This is at which point we consider the hood into safety phase. Now, safety phase, hood should never get there. This is at which point you have to really address your administrative controls. Hood should never get there. But let's just say you do get into safety phase. We still have to guarantee it'll never be released exceeding 50% of the TLV. So still 50 times lower than what ACGIH, OSHA, or NIAR says. We take the lowest PPM value for any of those three governing agencies to determine what our TLV is that we allow to be released. And then, again, 50% is our guarantee for 1/12 of the filter life cycle. That's our guarantee. So you have plenty of time to make the changes in the filters before we can no longer guarantee your safety. Again, hood should never get into safety phase, but you do have belt and suspenders and redundancy built in. Now, as part of our smart technology, we can connect each one of these hoods, any one of these products, really. You could tie it into your IT infrastructure or your patch panel, and you can get real-time data feeds of the performance of that product. What's the value behind that? We have the light, it's an indicator. If it's steady, it's working. If it pulses followed by a beep, you know what that failure point is. What's the purpose of that smart technology that we're able to integrate to, which is called our eGuard? It really helps establish better laboratory practices. How? Well, you can extrapolate data from this system, and you can determine that, hey, we're noticing that hood 10 in lab 330 there's always a phase velocity alarm. Why is this? It allows you to investigate this. And then you realize that Joe is not using the hood right, sash is all the way up, hood's blinking, nobody's worrying, he's in the hood, playing with his chemicals. Well, now we have to have a discussion with Joe, train him on the proper use of a filtered or of any fume hood, but of the filtered fume hood, and tell him, understand, containment is critical. Without containment, a molecule doesn't care. We have to contain it and make sure we have to have a proper flow rate. So we create that barrier. That's the intent of a fume hood. So a lot of value built into the product, a lot of safety redundancy. Additional standards we adhere to is ANSI Z95, CSA Z316, ASHRAE 110, and NFPA 45, 2019 and 24 editions. I'd like to talk about this structure real quick here. In some of those standards, they state that you must have a fume hood structure that is the same structure as a ducted fume hood. That's what this product plays. That's the same structure, same research grade structure that you're all used to using. That's what NFPA states. That's what ANSI Z95 states and CSA Z16. It's not necessary in all jurisdictions. There's some AHJs that want you to comply to NFPA 45, others that just don't really follow the guidance. And that's okay, because these products are just as safe. It's just a matter of the compliance standards. Difference again, double wall constructed hood, vertical sliding sash, single wall constructed hood, very easy to install, reversal sash style product, which allows you different access points to your chemistry or your handling application, whatever that may be. That product sets up in minutes, comes to your facility completely knocked out. This product's a little bit more challenging to do the installation, but all of them remain completely flexible. So let me just touch on some case studies too, trying to keep this within the time frame. Tammy, can you go to those case studies for me? While Tammy's pulling that up, I do want to talk about the halo. The halo, again, is designed to capture fugitive emissions in a lab. So if your lab smells or you're having concerns with some of your employees or your staff members noticing that they have continuous irritation of their lungs or their throat, or they're now become asthmatic or skin rashes, it's highly likely that they're impacted by the air they're breathing and what's around them. And that halo is designed, again, to capture those future emissions and be an equivalent air change rate system without impacting the HVAC system. Now, one of these halos will process about 3,500 cubic volumes of air effectively and provide you one additional air change rate per hour. We see, flavor and fragrance, food and beverage, and pharmaceutical companies really love the halo because they have high, heavy emissions. Yes, flavor and fragrance. I'm sure some of you in New Jersey may be in a flavor and fragrance company. They have high emissions. Some of them are just odorous, but still high loads of concentration can certainly impact that individual. And then, of course, the storage cabinets, I touched on a little bit earlier. Tim, are you able to pull up the case studies?
Yes.
So Tammy's going to pull up some case stories that really show how we became the cornerstone to companies achieving LEED Platinum certification and even ZNE, and the impact, again, of filtration, how the project started, and once they started value engineering, how impactful this technology was. Now, again, none of this is possible without the safety behind the product, without the company that stands behind the product. But now from what I just told you, that is us, certainly. We have the safety and the company that stands behind the product and tremendous credibility. So this project, Bristol Community College, was the first awarded ZNE facility in a Zone 5 climate. It started off as a high efficiency design lab, which means they had high efficiency fume hoods, and they had different efficiency systems built in, and you'll see in the next slide. But what they found out at the end of the day is that because of the ducted fume hoods, they would have consumed over half of the PV rays installed within Bristol Community College. So they had a value engineer because they weren't going to be able to achieve what their initiatives were set out to do. So installing 17 filtered fume hoods allowed them to reduce their CFM output from 70,000 down to 24,000 CFM, and they were able to achieve ZNE without additional costs. Next slide, Timmy. And this will show you what that design looked like. First, on the left-hand side is the high efficiency design. It's great. I'm glad they looked at high efficiency and reducing the energy loads. Wasn't going to do it. So when they installed filtration, not only did it allow us to take some energy use off of the solar panels, but it also allowed for natural ventilation. It now allowed for heat enthalpy wheels, heat recovery systems, and a completely filtered lab. That's now a safer environment because it's continuously filtered. One thing I like to point out is, many people think that ducted fume hoods have filters at somewhere in the exhaust system before these emissions are released out into the atmosphere. Unfortunately, that's not the case. All these emissions, with the exception of NOx, SOx, and some particulate matter, are allowed to be released at 100% of the TLV as per EPA regulations. And within 450 feet, they want that to be reduced down to 1% of the TLV. I don't know who's monitoring that. Nobody. So they just say dilution is the solution to pollution. Just let it go and let the environment take care of it. Well, what happens? Wind blows. Yes, the stacks have to be 6 feet high, and they're hoping that's high enough for wind not to re-entrain these pollutions back into your lab. But I assure you it's happening. And not only is it happening to your facility, it's happening to adjacent facilities. Next slide, Tim. Okay, so part of achieving ZNE is really understanding what your EUI is, your energy use intensity is per square foot at kBTUs. So when they started, the baseline was 290 kBTUs per square foot. When the high efficiency lab was designed, it dropped down to 230. So it had a 60 kBTU impact. The largest impact, as you see here, was adding the ductless fume hoods and addressing the ventilation. It dropped it down to 110 EUIs. And then, of course, they asked to add their architectural lighting, and they changed the users' habits. And ultimately, with the renewable energy, it allowed for ZNE. That's how we got there with Bristol Community College. Next slide, Tammy. We'll go through one more case study, and I'll leave it open for any questions because we're coming close to time here. The next one is Northeastern University, 77 filtered fume hoods. How did this opportunity start? Swing space. Anybody on the call here is swing space? You can leave that for after the presentation here. But swing space is a huge deal, especially in academic facilities. The students can't stop learning. So what are you going to do when you're doing a renovation? You're going to take those fume hoods somehow and put them in a trailer. Impossible with ducted hoods. So it started off as going with filtered fume hoods because of the flexibility by nature, but then realizing that, geez, these hoods really work. And what if we actually incorporated these into our design? How is that going to impact our facility? And ultimately, at the end of the day, that's what happened with Northeastern, and it came to 77 filtered fume hoods. Next slide, Tammy, I'll show you the impact there. So you see the impact of these 77 hoods. You reduce the air handling units themselves by 36,000 CFM. Now, remember, this is a school, so we're operating at about 2,000 hours a year. Your lab exhaust was reduced by 36,000 CFM. Your chillers were reduced by 260 tons. Your pumps and VFDs were reduced, and your boilers were reduced. So you're reducing embodied carbon because you don't have as much MEP equipment needed to operate your lab. And therefore, you're increasing your gross square footage for other areas, or lab space, office space, whatever it may be. So we're addressing the embodied carbon, and then we're addressing your overall operational carbon. Next slide, Tammy. And then Butler University. Touch on this quick. Longtime client, started off with just some filtered fume hoods. After many years, they've been a client of ours now going on 14, 15 years. They now have over almost 70 fume hoods installed. They have many equipment enclosures or containment ventilated enclosures around their rotary evaporators, storage cabinets, halo units. They've done cost analysis. What they found out during the original design of the first installation was we were able to save over $500,000 in energy, just incorporating the filter changes, again, just by installing the filtered fume hoods. Actually, when we did the assessment for Butler, we determined that the filters were going to last 24 months based on the analysis. They actually did not replace their filters to year 5. And they, unbeknownst to us at the time, they were running T-clip testings. They were sending the filters. They couldn't get them to break through. But after 5 years, they said, we might be pushing our luck. Let's change the filter. So the cost savings actually went up exponentially. So that, I don't want to go over time. I definitely want to leave some room for questions. But in summary, we must do our part in really trying to improve the overall energy that we use. And we have to know that labs are the greatest beast when it comes to energy consumption. And there are technologies out there. We just have to get past being what we're comfortable with in tradition and kind of shy away from tradition and accept change. Because if we don't accept change, nothing else is going to change. And we're really in for some dire days ahead of us. So we got to do our part. Obviously, I'm very passionate about what I do for a reason. First, safety, and then, helping the overall environment. So hopefully, our kids and our grandkids will live a healthier life. So with that, do you have any questions?
And while everyone's typing out their questions, I just want to share my screen for just a quick second, just to show you that some of the case studies and literature are hanging out inside the kiosk, as well as some web links and videos. And this talk will be on demand within 24 hours. So if you click on this button up here, all of the talks on demand will be in there. And you can also click this button to register for upcoming talks. And I will hand it back over and we'll see if there's a couple questions.
Perfect.
Are you able to see the chat, Jesse?
Yep. So how many halos would someone need? It went away. So how many halos would someone need? And then I lost it.
Need to provide adequate filtration for their lab.
So it depends. It's not a one size fits all approach. We have to understand how big your lab is in cubic volume space. And then we'll work with you. Maybe we can get reflective ceiling plans, come out and visit, understand how many air changes rates you have, and then we'll make a determination or a recommendation of how many halos will be required to provide the right solution for you and adequate air change rates. And then there was another question, what type of power is needed? Good question, and I didn't touch on that. Standard 110, plug it right into your wall. They run our largest hoods, this one and the one behind me runs on about 260 watts. That's it. Halo runs on 50 watts, half an amperage, so extremely sustainable.
How easy are these products to install?
Very easy, especially the capped air. They come to a facility completely knocked down. We have installation teams we work with, but literally these are wrecked within, I could build that hood 10 minutes myself, the one behind me in a half an hour, and you're operational and ready to go. As far as changing out of the filters, that question was just asked. Very simply, just gravity fed. You just lift them, place them, on the floor, put the new one on top. Very, very simple to do. And there was a question that just came up and I didn't see it. Could you read that for me, Heather, the last one?
Sure. Does the filtration use electrostatic principles and microfibers?
That would be on the HEPA filter. So had we integrated HEPA filtration, so I'll go back over here. This showed you a configuration of just carbon, but we can actually layer this 3 high. So we could put HEPA filtration below or above if it's going in a controlled environment or clean room, below if you're working with any type of powders or if you're doing any type of heating of your chemicals, so we can slow down the molecules to act for proper residency time within the carbon filter itself.
What are the capabilities to handle formaldehyde?
We have very strong capabilities for formaldehyde. Formaldehyde is extremely challenging because 0.75 as per ACGIH ppm is what you can be exposed to. So it's extremely challenging, but also it's challenging to detect formaldehyde. We have a special proprietary sensor that allows us to detect formaldehyde before we get to dangerous TLVs past the filter. We deal with histology, pathology labs all the time, and it's a very good application for us. So we have a high retention capacity. I think it's 275, maybe 305 molecular grams per filter that will be able to handle of formaldehyde. Again, before we see release exceeding 1%. So it's 0.00075 ppm. So it's very challenging, but we can do it. 55 years of innovation. It's not just about the carbon that's in this filter. It's how do you pre-treat the molecules? How is the carbon activated? How is this filter shell designed? We have to make sure we don't have any pass leak resistance internally in the chamber. So you have to have laser etched grooves so that the molecule bounces and finds a parking spot and just doesn't pass through. Because if it finds a smooth surface, it will go right through. Delicate balance of airflow is required as well. That's why you notice we have a fan module per column. So this would show you 2 different columns, each column having a separate fan module, because we don't want to suck 700 CFM through a 6-foot fume hood into a filter cartridge, because then you pull in air too quickly. And what happens when you pull air too quickly in carbon? Molecules go right by because it just doesn't have enough time to find that parking spot. Great questions.
Last question I'm seeing is you talk about energy savings. How is this quantified?
Very easily. So that calculation chart that I just gave you from Con Edison, and it's very simple. Now it's going to be variable depending upon what you pay per kWh, where you are logistically in the country, but it's very easy. We work with the client. What is your cost per kWh? How often are you operating the fume hoods? And then that system does the calculations and all the algorithms to quantify what we're actually going to save you as far as energy. We're also working with My Green Labs to quantify that as well and getting ACT labeling. So it's all there. This is real data. And as you saw, the case stories themselves quantify the energy savings behind the technology. Nothing's better than peer-reviewed real-world data, period. You can test anything you want in a chamber and you'll get it to look fantastic. But when you apply that in a dynamic setting, that's when it tells the true story. And we have well over, I don't know, 25, 30 case studies.
All right,
Great
that
question.
is all of them.
Excellent. Well, thank you everyone for your time. Enjoy your weekend.
Oh, we got one more last minute
more.
question.
Go ahead.
Ultra clean surgical suites require Lamar airflow. Is this true for these labs?
So laminar airflow. Yeah, that's what. Sure, when you're in a clean room, yeah, you need ultra clean environment. These hoods can be installed in that ultra clean environment because we can add ALPA or HEPA filtration at the top, so that whatever's coming out of that hood, there may be some fine carbon particles. The HEPA filter is going to capture that, and then whatever's going into that fume hood as well. And they're ISO 14644 certified, so you can get down to ISO 5 cleanliness with these filters.
All right, I think we got them all now.
Excellent. And we do have laminar flow hoods. I didn't really touch on those. I talked more about ducted hoods and extraction, but we have a complete line of ISO 5 containment enclosures as well.
Awesome. Well, thank you so much for joining us today, Jesse, and I hope everyone has a great rest of their day.
Thank you, everyone.
Thanks, Jesse.
Thank you, Diane.